Hi, Pre-Calc. We are going to start Unit 7, which is on vectors. And just to give us a little bit of a feeling for what a vector is, we're going to watch a clip from Despicable Me. So hopefully you can see and hear this okay.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh, ah! Shoot! So difficult sometimes to get it going back inside.
So that is Victor the Vector, and he is a vector because he has both magnitude, that's a force, and he has a certain direction he's going, and that is the definition of a vector. So, like we were talking about before, a vector has both quantity, or a vector quantity has magnitude and direction. Okay, so this is an example of two vectors. They are not equivalent because they both have the same direction, but they don't have the same magnitude. Magnitude can also be thought of as length, so they don't have the same length. If we look at example 2, those are also not equal because they both have the same magnitude, they're the same length, but they're going different directions. The only example that has equal vectors, where vector A is equal to vector B, is example 3, because they're going the same direction and they have the same magnitude, they have the same length. So if you notice above the little vectors, they have an arrow. So that arrow is actually, it's hard to see here, but it's actually half an arrow, so it kind of goes like this. So it doesn't have like the other full point. So that's really what's on top. So they're denoted as half an arrow, at least as far as the tip goes. Magnitude almost looks like absolute value. So if we want to know how long is the vector, that's the same as the magnitude. It's denoted like this right here. Almost looks like an absolute value. And we're going to talk about how to find that as we go, not just in this section today, but in the next couple sections. We'll be calculating magnitude and also talking more about ordered pairs and ordered triples. So this just kind of denotes if a vector starts at the origin, this kind of gives us a sense of what it's going towards. It's heading to right 3, up 4. Or if it's three-dimensional, right 3, up 4, and out 5. So again, just some more kind of definitions that have to do with vectors. Equal vectors, again, same direction, same length. Here, vectors are going the same direction. Here they have the same length, so they're the same magnitude. These are opposite vectors, so they're exactly the same length, but they're going the opposite direction. Actually, one of these would be positive, and the other one would be negative. That denotes an opposite vector. And then parallel vectors are just like parallel lines. We're going to talk about drawing vectors, because in your homework for today, you are going to be drawing resultant vectors, combined vectors. So for example, if we put these two vectors together, if you looked at that little intro video of the woman talking about really what vectors are in physics, this is taking, pushing something in this direction with this force and putting it together with somebody else pushing the same object in this direction with this force, well, really, what is the final force and direction that that object is going? If one person is pushing this way and there's something else pushing another way, whether it be a person or some other force. So the result of that is what we call a resultant vector. So if we put this together with this, this is the result. There's two different ways we can do it. This is called tip to tail, because notice we're putting the tip of this vector together with the tail, the end of this vector. I can also take the exact same two vectors. Notice this is the same length and direction as this, right? And I can put them tail to tail. So I can just put their ends together like this. And the result would be whatever is kind of in the middle. So if I make a little parallelogram with this and draw the diagonal, but do you notice that this here, I'll try to highlight it maybe in yellow. This here is the same length and direction as this here. So those are both the resultant vector. There's just two different ways to get that. We're going to practice drawing that in the next slide here too. This is the incorrect way to do it, is if you did the tails together and you drew it down the middle here. If you put the tails together, you have to make a parallelogram out of it and go that direction. Okay, so I'll show you both ways here in the next. Okay, so like we were just talking about, we can draw these two different ways. So if I have two vectors, so let's say I'm going to do it the parallelogram method, then I put the two tails together, the two ends together. I try to draw parallel lines, so I'm trying to go opposite the one ray. Okay, well, pretty good there. So the starting point is where the two rays start, and the end point of that is just at the end of the diagonal. So you just draw on the diagonal when we do the parallelogram method. So this is the resultant vector. And if we did it using the triangle method, so the triangle method is going the tip of the one to the tail of the other. So the arrow to the non-arrow side. And again, if I start here at the beginning of the one and I go to the end of the other, notice I get the exact same resultant vector. It's the exact same. So, same thing. All right. I'm going to do the parallelogram method. So, just to kind of look at a few examples here. If I take this first example here, I'm going to draw a line parallel to that blue one. So this is parallel. It's not very straight. Let me try to just straighten that out a little bit better. So I'm going to go parallel to that, parallel to that. This is my resultant vector. It's what goes kitty corner. So this is the resultant vector. Okay? So now besides sketching it, we want to try to talk about what do we mean by magnitude and what do we mean by direction. Before we do that, just notice where the point ended up. The vector ended up right 4 up 5. Right 4 up 5. Okay? So in a couple lessons from now, we're going to talk about adding vectors together. We're putting two vectors together, and the resultant vector ends up, if we're starting at 0, 0, it ends up at 4, 5. So this is why we add vectors together, is to show what the two combined forces, what it looks like on a coordinate plane if we were going to start at 0, 0. Okay, but the magnitude is just the length. So one way I can find the length is, of course, by doing Pythagorean theorem. I was going to go in yellow there, if I can get that. Pythagorean theorem, which is, so this is about 4 this way, 5 this way. Notice that's the same as where the resultant vector ended up, was right 4 up 5. So I can actually take that and square it. So this is 4 squared plus 5 squared. 25 plus 16 is 41. And the square root of that, I believe, is about 3.6. Okay? So that's the magnitude. Now the direction relative to 0, if you remember from what we did before, it looks like this, right? So it's the angle that's formed kind of with the x-axis. Now there's 2 different ways we can write this. First of all, we're going to measure it. So take this protractor, try to spin it around, and line it up. Okay. And it looks like it's approximately, if we go here, 10, 20, 30, 40, 50, maybe about 55 degrees, approximately. So it looks like that red ray, it kind of falls between 50 and 60. Again, we're just estimating right now, because what we're going to do in the next lesson is we're going to find angles by using SOHCAHTOA, law of sines, law of cosines. So right now, it's just like, okay, this is about 55 degrees. That is the direction. So the direction is about 55 degrees. You know, another way we could put that, I'm just going to move this over a little, is instead of saying 55 degrees from 0, we can talk about how this is east, this is north, this is west, and this is south. So when we do the application problems, we can also say that this is 55 degrees north of east. North of east. All right, so you can kind of say it either way. So either 55 degrees, or you can say 55 degrees north of east. Let's look at a different example. I'll widen my screen a little bit here. Okay, so if I look at this next example here and I draw parallel to the green, parallel to the blue, this is the beginning of both vectors. That's also going to be the beginning of the resultant vector. We're going to go kitty corner, and this is, once again, the resultant vector. So this also has magnitude and direction. So we'll start with the magnitude again. And remember the magnitude, it comes from Pythagorean theorem. So this one ends up, my red one is a little bit funky, but it ends up at right 3 down 1. Okay, so that one should end up at right 3 down 1. And then we can find the magnitude, because if I did Pythagorean theorem, it would be 3 squared plus 1 squared. So I can just take that 3 and the negative 1 or the positive 1, it doesn't really matter. 9 plus 1 is going to be 10. And if we do the square root of 10, we get about 3.2. Okay, so that's our magnitude. That's the length of the vector. Now it also has a direction. So if I were going to measure this, So if I measure this here, it's about 10 degrees south. So try to find a protractor when you do this on your worksheet. Use a protractor to measure that. Otherwise, honestly, that's not the way we're going to do it in the next section. So if you want to approximate the degrees, that's okay as well. But it should be about 10 degrees. So the direction we can say is 10 degrees south. I put 2 U's. South of east. Okay. You know, if we really wanted to, we could, like if I started at 0, 360 minus 10 is 350. So I could say it was 350 degrees relative to 0. Usually when we do application problems, we do it relative to east and west. So of course, if that's north, this is east, and down here is south. So we're moving, you know, if we start out east, we're moving 10 degrees south of east is what that's saying. Okay, so again, we're just trying to get an idea of what we mean by direction in degrees and what we mean by magnitude. Magnitude is length, and the direction is just how many degrees it is from east or west or relative to 0. We're going to do one more because you have to do this in your homework as well. We're going to do one more where it is not on a grid. So just like the grid though, we're going to draw parallel lines to both rays. So I'll try to draw that as parallel as possible. So those are parallel to the other side. This is the end point of both of the vectors, so it's going to be the end point of my resultant vector, and not a very straight line, but this is our resultant vector. Okay? Now, magnitude is the length, right? Again, what we'll use, we won't be measuring with a ruler and a protractor from now on, but again, we're just trying to get the concept. But if I were to take a ruler here and measure in degrees, let's try to spin this, not in degrees, but centimeters. So starting at 0, it's about 6, pretty close to 6. We're going to go with that. So the magnitude is about 6 centimeters. That's the length. All right, which we also talk about in terms of force. So this is 6 centimeters. And then the direction is, again, relative to 0. We could either say relative to 0, or if we want to call this east, we want to call this north, we can do that as well. How many degrees is this? So I can bring up my protractor, try to spin it here, straighten it out. Again, we're just approximating. So if we look at this, it looks like it's about halfway between 60 and 70. So we're going to say it's about 65 degrees. And we can either say just 65 degrees relative to 0, or we can say 65 degrees north, because it's up east. Relative to the east, we went north. Now, another thing we could actually say for this, if I want to give it one more, I could say 90 minus 65 is 25. I also could have said 25 degrees east of north. Because if we were going north, Move the protractor. If we started out north and moved 25 degrees towards the east, we would end up at the same place. Okay, so we're going to talk about this more in the next lesson when we have application problems, and in that case we will use law of sines, law of cosines, and SOHCAHTOA to find magnitude and direction instead of by measuring.